Hello, my friends. We had a lecture. I'm just putting a follow up of that, of what we did. We started by saying how electricity has changed our lives. You can look at this and you will know that we use electricity for almost everything, for an oven, for iron, refrigerator, air conditioning, flashlight, communication, TV, radio, portable phones, you name it, and we use it. For few hundred years back, sunrise and sunset used to be determined by the length of a day. That used to determine the length of a day. In fact, news used to travel so slowly that messengers used to actually write it down and move from one place to another place, physically transmitting data. And that too, if the messenger survives the harsh environment and comes to the other side, only then. Otherwise, the news is gone, destroyed somewhere. And all data used to be stored actually on the brain, not on the computer. So, harnessing of electricity has helped us overcome all these difficulties and has made things easy for us now. So, let us see how exactly the electric current works. Or now you know that electric current is a flow of electrons. This is the common thing which most of us would have studied. Electric current is the flow of electrons. But tell me guys, why should the electrons actually flow? We are going to analyze that now in this next lecture, in this part. Okay. We would have also seen that the current flows from something called as a high potential to a low potential. High potential to low potential. What is this potential and all we are talking about? I want you to picture the flow of current something like the flow of water. Imagine you have a tub here and this has got some water, and you have one more tub at a higher tank. It's attached somewhere here, say it's attached here, otherwise it will fall off, no? And you're just connecting a pipe just like this. Now you will observe that the water does not flow because it's at a lower level. But if you put a pump here, the pump will use electricity, electric current, electric power, and then it will siphon this water and push it inside this. And slowly this will start filling. Without the pump, it is not possible to travel from a lower level to a higher level. Once it has reached a higher level, now this is called as a high potential, high level. Again, note that the water will not fall back into the tank unless you complete the circuit, just like that. You complete the circuit and allow the water to come inside. So this is called as completing the circuit. You have to create that pathway. So this is the water stored here is high voltage. So you are generating the high voltage by using a pump. We are going to generate that high voltage by using a battery. So the battery is like your pump. It creates a very high potential, and then we are going to take that charge to a lower potential. Another way of doing that is by continuously taking a silk cloth. Imagine you have a silk cloth and you just rub an iron rod on it. As you are continuously rubbing the iron rod, what will happen is you are creating a negative electrons on one side and positive on the other side. So you are actually creating, when you are rubbing, that is what the pump is doing. It's like pumping electrons. So you are creating a high potential. Now, if you keep another cloth here with less electrons and you connect this with a wire, what will happen is all the negative electrons will start flowing from the high potential to low potential, just like that. So, the act of rubbing the glass rod, the act of rubbing the glass rod on a silk, that is what is like a pump, acting like a pump. So, you are rubbing silk cloth, creating more electrons, and when you touch the silk cloth, the electrons start flowing. So, finally, what we are saying is that a high potential means a lot of charge. Imagine there is a lot of charge here, lot of electrons, and the other side you are keeping very less electrons or 0 electrons. Connect with a wire and you will see that the electrons will start flowing from high potential to low potential, and this is called as completing the circuit. Now, why should the electron flow? We will see that now. It is just like higher level to lower level. Okay. Now, also note that once we say that the electron is flowing, it is not the same electron that is actually reaching here. It is only a flow of electrons like this, meaning I wanted to imagine that this is a copper wire and you have these electrons here just like this. Okay, and you take one electron and just push it inside here, and as you push this electron will flow here, 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 and it will transfer the charge, and what comes out is this electron. So, if you push electron A, electron B is what is coming out, like a marble. Now, why should the electron come out like that? Now, this has got to do with something called as the atomic structure. Let us talk about a copper wire. Now, copper has got an atomic mass of 29. That means it has got 29 protons and 29 electrons. When you look at the structure, the orbit KLMN structure, you will see that the first 2 electrons go here. I will show the electrons in red. Then the 8 electrons 1, 2, 3, 4, 5, 6, 7, 8 will go here. Then 18 electrons will go here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 electrons. That is actually given by the formula 2n square. So, 2 into 1 square, 2 into 2 square, and 2 into 3 square. So, that is like 2 plus 8 plus 18. 28 electrons we have taken care of. So, there is one extra electron which is far away, we will call that as a green electron. So, all these green electrons are here. Now, these green electrons are orbiting like this. So, they are continuously exchanging, and this green electron is what is actually falling. So, you are pushing the black electron, say, I am just giving an arbitrary color. This black electron will push this green, this will push this green, and finally this green is coming out like this. This is how the electric current actually moves. So, we need free electrons. If you do not have free electrons, then you will not get the electric charge. Okay. So, I will now show you a few diagrams before we proceed on this. I wanted to observe how the electrons are flowing along the conductor in this, and also in this observe how the loose electrons are moving, are transferring the energy. The loose electrons are slowly transferring the energy one after the other. It is not the same electron that is moving. This is something important. And here you have a battery. The battery has got all the positive charge on the left and the negative charge on the other side. So, this battery is what is used, or this power is what is used here. Now, when we are using a typical battery like this, and a bulb here. Okay. Now, the switch is off here. This is the positive part, this is the negative part. Okay, so this bulb in the beginning will not glow because remember I told you that the pipe has to be connected, only the water will fall from higher potential to lower potential. So we are going to now connect this wire like this. Now the switch is closed. Now the bulb will glow. Why? Because an electric current will start moving from this direction, from positive to negative. This is the direction of the current I. However, the electrons are flowing in the opposite direction. The electrons are flowing in this direction. So the electrons flow actually in the opposite direction of current. Because the first time, why they made this in the positive direction is because earlier they used to think that it is a positive protons that are moving. That's why they made the conventional direction of current from positive to negative. Anyway, that doesn't matter, it's just a convention. So finally we are saying that when you have a lot of charge here, these positive charges are going to repel, and when you connect it, they are going to push these electrons in this direction, and the electric current is set up. Now once the electric current is set up, there is a resistance generated on this wire. This is called resistance. It is something like friction. It will not allow the free flow of electrons. So because of that, the wire starts getting heated. And if the wire starts getting heated, if it's a very high resistance, what happens is it starts glowing by emitting the heat as well as light. And that's how we get, that's the principle of a bulb or a heater or something like that. So the voltage is to create a high potential, and that is generally done by a battery. Okay, you have the negative terminal which repels that electron and which pushes the next electron. Energy is transferred like a wave. Energy, like a wave, it moves. The flow of the electric energy is what we are talking about. And in a regular copper, you will see that there are around 3.2 into 10 to the power of 22 molecules. So each one is going to contribute an electron. So it's going to be a free flow of electron. So the electrons are continuously moving and they are creating the electricity. Now this can also be given, so in a battery, what is happening in a battery is that in a battery there is positive here, negative here. And this is done by a chemical reaction. So the chemical reaction is separating the electrons. So when you connect the wire to this, automatically the current starts flowing and the bulb glows. You can also generate electricity by using a simple potato. If you take a potato like this and you keep a coin here and a nail here, nail and a coin, and you connected that with a wire and put an ammeter here, surprisingly the ammeter records a certain reading, and that reading is around 0.2 volts. That is not enough to light a bulb, unfortunately, but you can use that. If you put around 6 or 7 potatoes and join them like in series, you may get a good power which is probably just light up a bulb. So this is the whole idea of the electric current. Now from here we take on from the Ohm's law and other things. Thank you.